Hi, my name is Brandon. Welcome to part 2 in my series on protocol-independent multicast. In part 1, we discussed and configured Cisco's AutoRP. It's a proprietary protocol. We used an RP mapping agent in order to elect a rendezvous point for that multicast domain. Here in part 2, we're going to be doing the very same thing using a bootstrap router. A BSR is used to discover and announce RP set information to an entire multicast domain. I have Wireshark captures on the link between R2 and R4, as well as R1 and the switch, here connecting to R2 and R3, in order to solidify and really understand what's going on under the hood. Here are those packet captures. They are currently running. We can see OSPF hello packets periodically being sent between R2 and R4. This is R1's packet capture. Okay, so let's get to work. In order to make my life a little easier, I wrote on Notepad a little configuration to get everything started. I will be copying and pasting this into the configuration for all 6 routers. What this is doing, it's enabling our multicast process, and we are enabling PIM Sparse mode on gigabit 1, 2, 3, and 4, and loopback 1. Let's do the same on R2. Okay, excellent. So now we see our designated routers coming up between our links between routers. We have sparse mode effectively configured in our environment here. Now, I'm going to go to the packet capture between R2 and R4. I'm going to select and configure a BSR candidate. Okay, here's our packet capture. We now see PIM hellos between R2 and R4. If we look into the packet captures themselves, we have many options here. With a variety of information. Let's go on R4 and select this as our BSR candidate. The way we do that is with this command, ip-pim BSR candidate. We have to select a loopback, well, an interface. I will be using loopback 1, which for R4 is 4.4.4.4. We're using loopback 1 as our BSR candidate. Now, we can immediately see on our packet capture a bootstrap message was sent. This bootstrap message was sent to all PIM routers, 22.224.0.0.13. It's advertising itself as the BSR. Nothing at this point has really changed. We are simply advertising this loopback 1's interface as the bootstrap router. If I were to go to the packet capture on R1, what we will see is a bootstrap message right here. This was flooded across all PIM sparse mode interfaces, so R1 was able to receive it. And we can see that information is the very same, BSR. Now, we're going to go back to our packet capture for R2 and R4. On R2, we are going to configure loopback 1 as the RP candidate. What this should do is we should see an RP candidate announcement message on Wireshark, and we should see a bootstrap message from the bootstrap router acknowledging this, acknowledging R2's loopback interface as the RP for this environment. The way we do that is with ip-pim RP candidate and select our loopback interface. There are a variety of other add-ons we can select here: interval, priority, and group list. I will leave this blank for now. Now, here we can see R2's loopback interface 2.2.2.2. is sending a candidate RP advertisement. This is a type 8 message. A bootstrap message is a type 4. We can see that here. So R2 has sent its candidate RP advertisement. This is saying, hey, I am the RP for this group. And we can immediately see the bootstrap router response. Now, this bootstrap message is sent to all routers, all sparse mode interfaces within this domain. We can see a bootstrap message is now being sent. The bootstrap router is still 4.4.4.4. However, for this group, which is the entire multicast group, we have one RP count. And that RP count has this address, 2.2.2.2. At this point, if we were to look at any router, let's actually do it. Let's go back to R1. Here we can see the packet capture for R1. On R1 itself, let's do a show IP PIM RP mapping. With this command, we should be able to see who is the rendezvous point mapped to R1. On the packet capture itself, on R1, we can see that from 100.0.0.2, which is R2's interface, we are getting a bootstrap message saying this is the BSR. For this group, this is the RP, 2.2.2.2. And we can see and confirm that on R1, we now have an RP mapped. And that is router 2's loopback interface. And where is the source? It is the bootstrap router we just configured. Now, additionally, what we're going to do is on R5, we are also going to set this as an RP candidate. However, we're going to make the priority higher than what R4 is currently set as. Let's go back to our diagram so you can have a visual for this. So at the moment, R2 is our RP and R4 is our BSR. Let's make R5 another RP. The way we do that is with the same command, IP PIM RP candidate, select an interface, which is going to be loopback 1. This time we're going to set the priority to something higher than 0. We saw in our packet capture that the priority was 0 for R2. We're going to set this to priority of 100, a higher number than what R2 was set to, which was 0. We can see our tunnel interface is coming up. Even though this is on the RP itself, a tunnel should be coming up on all of our routers to the RP itself. Now, the RP was R2. However, R5 now has a higher loopback interface, a higher IP address, so it should take over as the primary RP for all of our routers. And we can see eventually another tunnel will come up, and we will see that to R5. Let's go back to our packet capture, and let's take a look and see what that bootstrap message is now advertising. Let's go back to R1. Okay. Here on R1, we should now see 2 RPs. And we do. So this is a bootstrap message coming from the bootstrap router. We can see for this group, we have 2 RPs. One has a priority of 0, and one has a priority of 100, which we set as R5. RP0, 2.2.2.2, and RP1, 5.5.5.5. So if we go back to R1 and do that same show RP mapping, we should now see 2 rendezvous points. This may take a second to load. It's slowly loading, but we can see 2 RPs at this point, and we should see the priority difference between them. Our info source is 4.4.4.4, of course, because that's our bootstrap router. Perfect. So we see 2 RPs, loopback interface for R2 and for R5. The last thing we're going to do at this point is what we did in the last video as well. We are going to confirm that multicast is working and that we are going through the RP, which should be R5, in order to deliver multicast messages. We are going to go into a static interface. I'm going to go in R6's interface gig 3. And on this interface, I would do an IP IGMP join group, and I will pick an arbitrary group. So now this router's interface will be joined to this multicast group. And from R6 again, from R1 again, I will ping the group that I just joined on R6. And I should get a response. We can see our packet capture, we see our pings going through. We also see a PIM join, which is perfect. This is what we want to see. So we have R1 sending a PIM join message. This is a type 3 message. We know this is a join because we see in group 0, number of joins 1, and 0 prunes. R1 is joining the group to 232.1.1.1 and sending that to this interface, 100.0.0.1, which is the interface leading to R5. So we got a response here. We know multicast is working. Let's check the RP mapping for this group that we just sent pings to. So the RP for this is actually 2.2.2.2. This is the one I configured first, which is likely why the RP is set to this. So we have now confirmed using Wireshark. We saw bootstrap messages, we saw RP candidate announcements, and we saw subsequent bootstrap messages be flooded out containing all of the RPs within that bootstrap message. We know multicast is working, and we have configured a bootstrap router. Thank you for your time. Thank you for watching. Until next time, thank you.